Hello, everybody. This is Teacher Yong Lam, and you are viewing the Common Mistakes Analysis for our P3 HAL Math Mock Test 7. Right, so in this video, I will be going through 8 of the commonly mistaken questions, right, in this test paper as shown in the analysis below. There is a good mix of enumeration, word problems, and calculation topics this time. So without further ado, let's get started with our first multiple choice question. Question 18. Right, question 18 is asking, there are some two-digit numbers, let's underline the keywords. There are some two-digit numbers whose ones digit and tens digit have a difference of 6. How many such two-digit numbers are there? Now, Teacher Yonglam would like to clarify, right? At first, there was a mistake in the question, so I have updated the choices. With the new set of choices here, can you find the correct answer? Okay, so how do we do this question? First, we need to understand that we are finding two-digit numbers. And when the question is asking us to list out any number of digits, right? One digit, two digit, three-digit numbers, it is good to label the place values before you start listing, right? So we have our tens place and our ones place. Now we say they have a difference of 6, right? The two digits have a difference of 6, meaning when I perform subtraction, then the result will be 6. Right? However, normally people will think, oh, okay, if I have a difference, that means I am taking the bigger number minus the smaller number. So of course, I will have a bigger number first. Okay, so maybe I can say that the tens is bigger than the ones. And then the difference is 6. So the ones, you need to plus 6 to get your tens. All right, so an example will be ones is 7, ones is 1. Tens is 1 plus 6, which is 7, right? Then ones is 2, tens is 2 plus 6, which is 8. Or ones is 3, tens is 3 plus 6, which is 9, right? So some of you might stop here, but there are some common pitfalls in this question. Number one, your ones digit, which is the smaller digit, could actually be a 0. And then 0 plus 6 will give you 6, right? Some of you might miss this case out, right? Giving an incomplete answer. Okay, so when you are listing numbers, consider, right, if the smallest digit is the ones or the tens, could it be 0? Here, ones is not the highest place value, so it's possible to include 0 as the ones. All right, so that's the first pitfall. The second pitfall is when I say difference, I actually didn't mention which digit is larger, right? So you might assume the tens is the larger, or you might assume the ones is the larger. So what if tens is the one that is smaller and I add 6 to get the ones? Is it possible? Yes, but in this case, can I still start from a 0? Unfortunately, you cannot, right? Because this time, tens is the highest place value, so it cannot have 0. So it has to start from 1. 1 plus 6, 7. 2. 2 plus 6, 8. 3. 3 plus 6, 9. Now, of course, I don't list out 4, right? Because 4 plus 6, 10 is not a digit. So altogether, there will be 1, 2, 3, 4, 5, 6, 7, right? There are 7 such two-digit numbers. All right, there was a tiny mistake in the question at the start, right, for the question paper, but we have updated it. So hopefully this has been made clear, right? So this is one of the enumeration questions that I wish to go through. With that being said, let's move on to our next question, which is question number 22. Now, in this question, we say that 12 and 21 can form a pair of two-digit numbers, which one number is obtained by reversing the digits of the other, right? For example, 12 become 21, right? You see, I'm swapping the digits. How many such pairs have a difference of 18, right? So let's get started with an example given to us, right, which is 12 and 21. We want to check their difference. So upon calculation, you will see that 21 minus 12 is equal to 9, right? But we want a difference of 18. So how do we do this? Perhaps let's try to see, right? Is there any examples of these pair that will give me a difference of 18, right? So we know that the first number here, 12, the tens digit is 1, right? And the ones digit is 2. So 2, 1, and 1, 2. Maybe we try to fix one of the digits and find such a pair, right? So for example, maybe I will try 13 and 31. Will they give me a difference of 18, right? So the first part is really just trying to get an example, because without an example, it's pretty difficult to find the pattern, right? But luckily, 31 minus 13 is equal to 18. Hey, so we found such a pair. Now let's move on to the next possible case, right? Maybe you might think, hey, can I continue with 1 as one of the digits in this pair? Then you try 41 minus 14, right? That's the next biggest number. Sorry, the next smallest number. So 41 minus 14 is 27. And you realize, hey, the difference is suddenly bigger than 18. So I don't consider it. In fact, should I even consider bigger numbers, right? 51 minus 15? No, right? Because you realize these two digits over here, okay, the difference is getting bigger and bigger, right? From 2 and 1 to 3 and 1, 4 and 1, 5 and 1. The difference of the two digits in this two-digit number is getting bigger and bigger. So as a result, if you subtract itself and the reverse of it, the results will also be bigger and bigger, right? Which is not what we want. So don't bother trying to continue. So we have found one example, which is 31 minus 13. Let's try the next example, right? The next example will be if we don't include 1 as one of the digits and we consider the next smallest digit, right? What if I have 2, right? The smaller digit is 2, then maybe I can try 23 and 32. Will that give me what I want, right? So just now we considered what if we include 1 as one of the digits in these numbers, right? After we are done with that, now we consider, right, if 2 is the smaller digit. 32 minus 23 is 9. Oh, too small. 42 minus 24 is 18. Ah, this is just nice. So we have another pair, right? 42 minus 24. Okay, it's 18. Both of them give me 18. Now, of course, we can stop here, right? If we choose a digit that is larger than 4 to pair up with 2, we will have 52 minus 25, which is 27. This is too big, so we can stop considering it. Okay, so now let's consider the next case, right? What if our smaller digit is 3, right? Then we pair up with another digit greater than it. For example, 43 minus 34. Is it possible? Hey, this one give me 9. Then 53 minus 35 is equal to 18. Oh, we found another case, right? So 53 minus 35 is equal to 18. All right. So at this point, I have listed up 3 examples, right? 3 pairs that you give me a difference of 18, right? Please take note, 31 and 13 is the same pair as 13 and 31, okay? The order of the numbers, they don't matter, okay? Because they still count as the same pair, same combination. Do you notice any pattern within the 3 pairs other than the fact that they subtract each other to get 18? Now, let's look at the first pair. We have 31 and 13 made up of digits 3 and 1. The next one is made up of digits 4 and 2. The next one is made up of digits 5 and 3. You will notice that within each pair, right, the 2 digits needed to form 3 and 1, the difference is 2. Right, 4 and 2, the difference is 2. Right, 5 and 3, the difference is 2. So you see, essentially we are simplifying this problem into finding how many pairs of digits have a difference of 2. Right, so can you list out all the other pairs? There are 6, 4, 7, 5, 8, 6, 9, 7. Now take note, do not include 2, 0 because 20 minus 0 to 8, this is not a 2-digit number. So I don't need to include it, right? I need to make sure the 2 digits that I use can be used to form a pair of different 2-digit numbers. Now each of them, the difference is 2. So let's test out. 64 minus 46 indeed is 18. 75 minus 57 is 18. 86 minus 68 is also 18. Finally, 97 minus 79 is also 18. So with that, these are basically all the pairs that we are finding. There are 1, 2, 3, 4, 5, 6, 7 of them, right? So my answer is B, 7 such pairs. All right. And fun fact, right? This actually extends to other difference between your 2 digits chosen. For example, let's say I choose the digits 6 and 2. Right? Can you guess what is the difference of the two-digit numbers formed by using these 2 digits? Right? So you realize 6 minus 2, the difference between the digits is 4. Then 62 and 26, if I subtract them, the result they will give me is 36. So it is just nice 4 times 9. And just now, 18 is just nice 2 times 9. So this is a very interesting property that involves the place value principle, right, of these digits. Let's try another example. Say 7 and 1. Right. So what is the difference? 71 minus 17 is 54, which you can write as 6 times 9. And would you look at that, right? 7 minus 1 is 6. So these are some very interesting properties, which hopefully you will remember next time you see, right? You are forming two-digit numbers using digits and their reverse. Okay, so that is question 22. Now, let's move on to the next question, right, which is question 24. This is a logical reasoning question. Alex, Benny, and Kathy teach language, math, and science respectively, right? So we have three people that are teaching three different subjects in school, right? Each teacher is teaching one subject. So this question is actually asking us to match each person to the occupation or to the subject that they are teaching. And they gave us three hints. It is known that, number one, Kathy is older than the science teacher. Number two, Alex is a different age from the math teacher. Number three, the math teacher is younger than Benny. Now, the question is asking us to match each person to their subject, and then they are asking, who is the science teacher? Now, this logical reasoning question is quite a basic one. In this question, we are doing two things. Number one, like I said, we are doing 1-to-1 matching. Right, we want to match each person to the subject that they are teaching, right? And there is only one person for each subject, one subject for each person. Actually, if you read the hints carefully, there is a second thing we are doing, right? Which is actually comparing. And in this case, we are actually comparing the ages of the teachers, right? We see that the uses of the words older, younger, different age, right? We are comparing the ages of the teachers. Now, just a reminder, for these sort of logical reasoning questions, for every function, for everything you're going to do, there is one thing that can help you, right? There is one tool. For one-to-one matching, what we usually do is we draw a table to match the name information to the subject information. When we are comparing, it is best to draw what we call a magic arrow or a number line, timeline, whatever you call it, so that we can arrange the things that we are comparing very clearly. So let's see how we can use them in this question, right? Starting with the obvious goal of this question, which is to do matching. We want to match each person's name to the subject they teach. So let's draw a table. For each row, there's going to be one person's name, right? ABC. For the column, I'm going to include the language, math, and science, which is the subject they are teaching. Okay, and now let's try to eliminate some possible pairings or some possible matchings. Look at statement one. Kathy is older than the science teacher. What does this statement imply? Now, can I say teacher Yonglam is older than myself or teacher Yonglam is taller than myself? No, right? I cannot have a different age with myself. That means Kathy and the science teacher are different people, right? Kathy is not the science teacher. So if you see a impossible matching, you can cross out the corresponding row column cell in the table. Likewise, Alex is a different age from the math teacher. So Alex is not the math teacher. Math teacher is younger than Benny. Benny is also not the math teacher. That means Kathy is the math teacher. And Kathy is also not the language teacher, right? Kathy is the math teacher. She's not the language teacher. And now the question remains, A and B, who teaches language? Who teaches science? Okay, so with the matching information alone, it's a bit hard to tell, right? Because I didn't have anything else to eliminate, right? So we have to look at our second piece of information or second group of information, which is the comparing of their ages, right? What more information can we get by looking at the comparison information? Let's take a look. So to do that, first, I will draw a magic arrow, right? In order to help me arrange the ages of them in a row. Right, so let's determine what are the two extremes. We will have the younger side on the left, older side on the right. Right, actually, it works the same if you flip around, right? As long as you label them correctly accordingly. So now we already know Kathy is the math teacher. So let me just label Kathy here. All right. And we look at the clues again, this time focusing on the ages. Number one, Kathy is older than the science teacher. Okay, so in that case, the science teacher is younger. Next, Alex is a different age from the math teacher. I know it's a different age, but is it a younger or older age? Unfortunately, the second sentence doesn't give much information, so we should look at the third. The math teacher is younger than Danny. Oh, the math teacher is younger than Danny. So this math teacher should be on the younger side. Danny is on the older side. And from this information, we now realize Danny can only be teaching language. And the last person, Alex, is the science teacher. So the answer is A. So you see, one single logical reasoning question, we have reviewed two main tools, two main purposes in logical reasoning problems. So hopefully this is helpful when you see these sort of questions next time. Okay, so we are done with all the MCQs that I would like to go through. Now let's take a look at our short answer questions. Okay, let's take a look at our first short answer question. Now, again, this has a little mistake at the start, right? Originally, I gave the answer, or rather the question statement 2382. I have changed it to 1382. Anyway, let's just take a look at this question. Mu added two three-digit numbers. The tens digit of one of the numbers is 3, right? So originally, one of the number, the tens digit is 3, but it was mistakenly written as 1. The hundredths digit of the other number is 5, but it was mistakenly written as 8, right? So there were two mistakes made. And after these two mistakes, the sum obtained is 1382. We want to find the original correct sum. Now, this time, this question is similar to what we see in the last mock test, right? And you will notice that, right, the key here is whenever I accidentally change one of the digits, the value of that digit, or rather that place value, will change. And that will cause the sum overall to change. And we want to find the correct sum. We want to work backwards. So let's start off with assuming that the correct sum is a placeholder number. Right, so let's give a placeholder for the correct sum. Assume the correct sum is a triangle or one unit, right? It's up to you to represent it. So from this correct sum, the one unit, how do you make it reach to 1382? That is because two mistakes were made and that causes the value of the number to change. Right, so let's take a look. In the first mistake, the tens digit was originally 3, but it was seen as 1. How does this affect the value? Okay, so if the tens digit is originally 3, then that means the value of the number is originally tens digit of 3 originally carries a value of 30, but it becomes 1. So the value changes to 10, which means the value increase or decrease. That's right, it becomes smaller, so it is decreased by 30 minus 10 equals 20. So the first mistake causes the value to decrease by 20. But that's not all. We still have our second mistake. This time, the second digit that is wrong is the hundredths digit of the other number. The hundredths digit of the other number originally is 5, but then it was mistakenly written as 8. So that, of course, will change the value of that digit, right? Or rather, that place value. So let's look at the value. How does it change? Originally, when the hundredths digit is 5, what is the value that it carries? This time it's hundreds, so it's 500. But now when I change the hundredths digit to 8, the new value is 800. It causes a increase or decrease in the value. From 500 to 800, the value is getting larger. So we are increasing the value by 800 minus 500 equals 300. So now we have a new increase of 300 in our value. And after I decrease by 20 by mistake and increase by 300 by another mistake, I finally get the sum of 1382. With that, we can find the correct sum, right? You can work backwards. So now you realize that how do we find the correct sum? First, minus 20 and then plus 300. That will be the same as plus 300 minus 20, right? Which is plus 280. Something plus 280 equals to 1382. So to find the original correct sum, it will be 1382 minus 280, which is 1102, right? And that is how you get your answer for the initial correct sum. So when you see these sort of questions, always think about how does changing the digits change the value and thus the sum, right? It is a hidden working backwards question in some sense, right? You can also do this using a train diagram. All right, so this is how you do this question. And without further ado, let's move on to our next. Right, our next question is question 29, which is actually a fundamental time word problem. Right, maybe it's because the way I express the time confuses you a little. But let's read the question. A lemonade stand started selling lemonade at 20 minutes to 9 in the morning. What does 20 minutes 9 mean? It finishes selling at 5 minutes past 5 in the afternoon of the same day. What does 5 minutes past 5 mean? How long did the lemonade stand operate for? In minutes. So we are finding the total duration in minutes. But first, the most important question is, what is the meaning of 20 minutes to 9? Now, this is a way to express time in words, right? Instead of our usual, 8:10, 8:30, etc. 20 minutes to 9 means that we are almost reaching 9 o'clock, but we still need 20 minutes more to reach 9 o'clock, right? We need 20 minutes more to reach our 9 o'clock. In other words, it is 20 minutes before 9 o'clock. Now take a look at your clock. If you want to go 20 minutes before 9 o'clock, what time will it be? It will be 8:40 a.m. Right? Okay, so that's the meaning of 20 minutes to 9. Just think about it as, right, how many minutes do you still need to reach your desired full o'clock? Now, another way to express time will be past. 5 minutes past 5 means we have 5 minutes after 5 o'clock, right? We already passed 5 minutes since the full 5 o'clock. And since it's the afternoon, so the time will be 5:05 p.m. All right. So these are two ways to express your time in words. And usually the number of minutes here will be at most 30. So for example, if I have 8 o'clock to 8:30, I will use past, right? How many minutes past 8? However, if I go from 8:30 beyond, right, 31, 32, 33, so on, right, to 9 o'clock, right, just before 9 o'clock, I will use 2, right, to the next o'clock. How many minutes left to 9, right? For example, 8:40 is 20 minutes left to the next o'clock, so 20 minutes to 9. So with that being said, this question is basically asking how many minutes are there starting from 8:40 a.m. to 5:05 p.m. And we can draw a timeline to solve this problem. So get your ruler ready. Let's draw a timeline. Oh. Okay, so let's start from our starting time, 8:40 a.m. and our ending time is 5:05 p.m. When we are finding duration, is there any way that we could do to save our time and be more accurate? Actually, there is, right? All we need to do is to shift to the nearest o'clock. So from 8:40 a.m., what is the nearest 4 o'clock? The question already hinted at it. Actually, it is 9 a.m., right? 9 o'clock. And how many minutes is this duration? The question actually already told you, right? It is 20 minutes, right? Because 8:40 a.m. is 20 minutes to 9. I still need 20 minutes. So this duration is 20 minutes, okay? Likewise, 5:05 p.m., right? Before that, the nearest o'clock is actually just 5 p.m. And it's 5 minutes past 5. So I have a 5 over here, right? 5 minutes here. So actually, these two durations from the starting or the ending time to their respective nearest o'clock, the duration is hinted in the naming of the times themselves, right? So actually, it helps you as long as you understand what they mean. Finally, we just need to figure out from 9 a.m. to 5 p.m. how many hours are there. So you can just count, right? 9, 10, 11, 12, 1, 2, 3, 4, 5, right? That will be 8 hours. But remember, we want it in minutes. So let's quickly convert it. 1 hour has 60 minutes. So 8 hours has 8 times 60, which is 480 minutes. Finally, we will total up the number of minutes to get the total duration. That will be 20 plus 480 plus 5, which is 505 minutes. And that is how you get your answer. Okay, so here the main part is to really understand what does this naming convention of your time mean. Okay, and also how do they help you to find the duration. Move to the nearest o'clock, just count in 4 hours and the two parts at the side. Okay, that is the time word problem explained. Let's move on to our next problem, which is a page problem. Right, actually, I have gone through this in our live stream, but let's just have a quick review. Let's say I have a book with 252 pages, and I want to label the page numbers. How many digits are used to number the pages from 1 to 252? Now, hopefully, your first instinct is not to give me the answer 252, right? Because 252 is the number of numbers, right? But I am asking for the number of digits, okay, from 1 to 252. Now, when you look at this range of numbers, you will realize that not all numbers are the same, right? We need to classify the numbers based on how many digits they each have. Among the range 1 to 252, I have one-digit numbers. I have two-digit numbers. I have three-digit numbers. And we need to find out where are these numbers, right? The range for them. We need to find out how many numbers there are or how many pages there are. And finally, we count or calculate how many digits there are for each category, for each class. So let's just go class by class, row by row to find the number of digits. And let's start off with the first row, one-digit numbers. So from 1 to 152, where are my one-digit numbers? Obviously, I start from 1 and end at 9. So 1 to 9. 1 to 9, there are 9 one-digit numbers. 9 numbers, each of them has one digit. So the total number of digits is 9 times 1 equals to 9. We use multiplication. Now let's move on to our next group, right? Two-digit numbers. How many two-digit numbers are there? We first find the range, right? After 9, the next number is 10, and 10 to 99 are all my consecutive two-digit numbers. So 10 to 99 are all your two-digit numbers. How many numbers are there? Right? Please make sure you know the formula for it. To find the consecutive numbers, how many such numbers are there? You take the ending number minus the starting number, and don't forget to plus 1, right? So that you include the start. If I just do 99 minus 10, I'm taking away the first 10 numbers, which include 10 itself. But I want to bring 10 back into the range. So that's why I need to plus 1 to include the starting number. And there you have it. There are 90 such two-digit numbers. 90 numbers, every number has two digits. So 90 times 2, there are 180 digits. Now let's move on to the 3-digit numbers, right? Be very careful in your calculation. We start off our range from 100 and our last number, look at the question, don't copy the numbers wrongly. It's 252. So from 100 to 252, how many pages and how many digits are there? We find the number of pages first, right? It's ending minus start plus 1. And that will give me 153 numbers. Then each number has 3 digits. So we multiply, right? 153 numbers, each number has 3 digits. So in total, there are 459 digits. Now, we found out the number of digits in each category. Next, we need to find the total number of digits. So all we need to do is add them up. 9 plus 180 plus 459. That should give me 648. Right, so my answer is 648. All right, so there are this many digits used to number these pages. All right, and with that, let's take a look at 2 more questions that I want to go through. Right, the first one is a working backwards problem. There was a large amount of apples on the farm. First day, half of the apples, along with 18 kilograms, was sold on the first day. Now, this sentence might seem a bit hard to understand at first, but if you read it following the order, it just means I sell half of the apples and then I sell 18 kilograms. Okay, the next day, same thing happens, but I sell half of the remaining apples and then I sell 5 kilograms. Right? Plus 5 kilograms means another 5 kilograms was sold. At this point, 30 kilograms of apples remained. So we want to find out how many kilograms of apples did the farm originally have. Now, since it's a working backwards problem, the more speed efficient way is to actually draw a train diagram. Of course, you can draw a bar model, but if time is limited, I would say halving questions, just use train diagram. Right? So how do we do that? For a train diagram, we start off with an initial number that we don't know. Then we just follow the order of the story. Right. So first things first, on the first day, half of the apples were sold. Now, which should we track? Remember, the train diagram is used to track the remaining number. Do not track what was being sold, track what is remaining. On the first day, we sold half of the apples first. Now, if I get rid of half, then the other half will remain. So we want to find the half. And an easy way to find the half is to just divide by 2. Right? We divide by 2 to find 1/2. Then we can get another number. But remember, that is just the first step in the first day. On the first day, half of the apples along with 18 kilograms were sold, meaning after I sell half of the apples, I still sell 18 kilograms. Yeah, and that's part of the train diagram done. Now we move on to the second day. The next day, half of the remaining apples, so I still sell half first, plus 5 kilograms were sold. So I sell another 5 kilograms. When I sell more, the remaining will be less. That's why previously I minus. Here I also minus, right? Track the remaining. When I sell more, the remaining will be less. And there you have it, right? The actions for your 2 days are all done. And now there are 30 kilograms of apples remaining. Now that we have finished drawing the train diagram according to the story, it's time to work backwards. Do your calculations carefully for this, all right? So we follow the story and draw forward and then calculate backward carefully. When we calculate each step, make sure you reverse the sign to the opposite and then keep the number. So minus 5, forward, backward, reverse the sign, plus 5. 30 plus 5, 35. Then backward, right, divide by 2, reverse, times 2. 35 times 2, 70. Minus 18, reverse, plus 18. 70 plus 18 is 88. Finally, 88 times 2, 176. So there are 176 kilograms of apples at first, right? So by now, we have already practiced a lot of working backwards problems involving half, more than half, less than half. Hopefully, you'll get more and more confident with these sort of questions along the way. Okay, now with this working backwards done, we are left with our last question that I would like to go through, which is actually an interval problem that could be a bit different from usual. Let's read the question. Now, the perimeter of a field is 900 meters, and you might think this is a perimeter question. No. Okay. The perimeter of a field is 900 meters, meaning if I surround the field, right, the total length that I surround is 900 meters. The border of the field is 900 meters. If a tree is planted every 6 meters around the border of the field, how many trees can be planted around the field? Now, this question actually takes like one or at most two steps. If you know, right, what's the key concept behind it? Now, let's say this is a field, right? Since I didn't say what shape it is, it could be any shape, right? Let me draw a prettier shape. Maybe this is the field. Okay. Now, before I proceed with the question, let's start with a little small example. Let's say teacher Yong Lam decides to plant 1, 2, 3, 4, 5, 6, 7, 8. 8 trees around the field. And I tell you, the gap between each tree, or rather between two adjacent trees, is 6 meters. The gap between any two adjacent trees is 6 meters. Then can you find the overall perimeter of the field? Well, you realize, hey, this is actually just counting the intervals and then multiply by 6. So yeah, let's just count how many intervals there are. We had 1 already, 2, 3, 4, 5, 6, 7, 8. There are 8 intervals. So the total perimeter is 8 times 6, right? Each gap is 6 meters. So 8 times 6, the total perimeter is 48 meters. So that's how you can find the perimeter. Now, here is something interesting. I thought usually interval problems, your object is one more than the interval. Now, this is a special case. This is an interval problem in a closed loop. If it's in a closed loop, you will realize that I have 8 trees and also 8 intervals. The number of intervals and the number of objects is the same, right? They form a complete loop. All right. So if you see a closed loop interval problem, right, I am planting trees or placing lanterns, whatever, surrounding a closed shape, right, around the perimeter of a closed shape. It's a closed loop. Your number of objects should be equal to the number of intervals, provided that it's in a closed loop. So this is a special case, right, which is maybe different from if you have interval problems along a row or along a line. All right. So with that, we can now focus back on this problem. The perimeter of a field is 900 meters. That means the total distance that you can plant trees along is 900 meters. If a tree is planted every 6 meters around the border, so that means one interval, the length is 6 meters. So if you plant 6 meters, 6 meters, 6 meters, 6 meters, how many 6 meters can you space out, right, in a perimeter of 900 meters? You will just do 900 divided by 6, and you will realize there are 150 intervals. Now, since there are 150 intervals in a closed loop, that means how many objects do you have? How many trees do you have? You will also have 150 trees, right? In a closed loop, your objects and your intervals, the numbers are equal. And so that is how you can just do this problem in basically one step, right? The key point is to remember interval problems in a closed loop is slightly different from in a row, right? In a row, you still need to check, right? Are there objects at both ends? But if it's a closed loop, your number of objects and number of intervals around a closed loop should be the same. And with that, right, these are all the problems that I would like to go through for mock test 7. We still have mock test 8 and our in-person mock test coming up. So yeah, hopefully I will see you there. And that will be the end of today's video. Goodbye, everybody.